Hi everyone, Mr. E here with another Tinkercad Sim Lab tutorial. And in this one, we're talking about how to adjust our scene to change our gravity or add earthquakes. So after creating a simple design, like for example, bringing a sphere in and raising it up off the work plane, we can switch to SimLab by pressing the SimLab button. Now, when nothing's selected, you can click on your environment or your scene settings. And here you can adjust your ground material. So for example, I might want to turn my ground into a bouncy rubber-like material. You can also adjust your scale. So if your students are designing something like a bridge that's supposed to be in the real world 150 feet long, but in Tinkercad it's 12 inches long or 15 inches long, you can adjust your scale factor so that way all of your densities and materials and mass is proportional to that. And you can adjust your gravity. So by default, you can see that our G, or our gravity, is set to the Earth. And if I click on my sphere and set this to be bouncy rubber, we'll see what bouncy rubber looks like falling on bouncy rubber here on Earth, right? And that should be a pretty familiar sight to everybody if you've ever dropped a bouncy ball onto a nice like linoleum floor or bouncy floor. It looks something like this. Now, if I were to click on my scene settings, I could change to, let's say, moon gravity. And now we'll see how this object falls and bounces on the moon. And with less gravity, you can see it's a slower reaction and has a little bit more response as we go ahead and click on our bouncy rubber based on the moon's parameters. And we could even move to something like Jupiter, which has a much higher force of gravity, and you could see a little bit more velocity there. Or you could go ahead and adjust your own custom gravity. If you want to put in your own number, you can adjust this slider anywhere from 0 gravity to, let's say, 3G, which is sort of cool as you're simulating what your shapes would look like in, let's say, outer space. If I give this a little bit of a push. Goodbye, bouncy ball. Now, something else you can do, which is super fun, is adjust the shake amplitude if you want to create something like an earthquake. So let me head back over to my design real quick and let's create a super simple tower, like as if I'm challenging my students to design some type of tower that perhaps they are going to make out of paper. So imagine that what I'm creating right now are little paper cylinders that students might cut and fold to make their tower, something like this. And let's bring what would be a flat sheet of paper right on top of these paper cylinders, and then maybe another row of paper cylinders and another sheet of paper, and then maybe just one more cylinder on top that has to hold something like a ping pong ball. If this was my Tower of Pong design challenge that students are designing for. So if we head over to SimLab and let me adjust my scene so we're on Earth and our shake amplitude is 0 at the moment, and I'm just going to make the ground grid again, so it's just normal ground. And when we simulate this, you'll see that we have a still prototype because everything is nice and balanced. And if I throw something at this, I can knock my paper apart until this tower falls, which is good though. It's a self-balancing tower. You'll see that it can hold our ping pong ball. But then what we can do is head over to our scene settings and increase the shake amplitude of an earthquake. So we can see we have a slight shake now, and my tower's still working fine, which is excellent. Let's increase to an amplitude of 3. All right, we're struggling a little bit. Looks like we're moving around, but not total chaos. My tower's doing pretty well. Let's go for a full 10. Here we go. All right, this isn't, oh boy. And I see that my prototype has failed at this level of shake amplitude. So a fun way to adjust your scene, test out your simulations with different gravity forces or different shaking amplitudes as you go, and just another great way that we can use SimLab. Something that you might add to a project like this is tracing the motion or the trajectory of our ball, which we can do by enabling a trace function and then graphing that trace function after a simulation. And if you want to learn more about traces or the other connectors or the other SimLab features that you can use and create with Tinkercad, check out my other tutorial videos. Thanks so much for watching. Please don't forget to subscribe, and happy tinkering.